Sean from Precision DynoTech here. In this video, we're going to talk about some more settings and features of the RevBench software, which is used with all of our data logger units that we sell. The DC1, DC2, and DC3 models all use the same software. So in this video, we're going to talk about logging a test and also our environmental corrections. So if you've been following along, I do have sort of a mock setup here. I've got a signal generator that's given us a RPM input here. I've got a little input for our torque for our load cell, and then you can see, of course, it's calculating power based upon those. So first, let's talk about environmental corrections. So depending on the device that you have, it may or may not have a weather station in it. Just depends which model you bought. If you have a DC2 or a DC3, you do have the onboard weather station. It's inside the unit, but it's got a very accurate sensor for barometric pressure, humidity, and temperature. So right now I do have a DC2 unit hooked up, so it does have that sensor. So right now it's actually auto-populating these fields. As you can see, I can't actually click and change them. So it's measuring that currently it's about 88.8 degrees. In my front office, the sun is beating down on me right now. So that sounds pretty accurate. I'm on the verge of sweating. Then we have the barometric pressure, 24.48. That's pretty low, and that's because I'm in Denver. So that is our current station pressure, as we call it. That is not the corrected altimeter setting that you would use if you were a pilot setting your altimeter. So if you're ever getting these values, make sure that you understand that this is station pressure, and that's what's used for calculating our correction factors. Humidity, 18.5%. So yeah, that's self-explanatory. Now, if you have a DC1, you're going to have to enter these values manually. So you hopefully have some sort of weather station, in your dyno room where you can get these values and input them in. If you didn't, or you don't have barometric pressure, you can simply look up your local airport, and they should have the station pressure, and you can enter that there. If for some reason you wanted to manually change these numbers and you have the weather station, so you don't want it to auto-populate this, simply click this checkbox. And that's going to allow you to input whatever you want, and the correction factor will update automatically as you enter in each field, as you see here. So I'm going to turn that off, and then after a few seconds, it'll definitely, update those values again to what's coming from the device, from the weather station on it. Right here for your correction, you can select right now one of 5 options. There's 4 correction factors, and the 5th is uncorrected. So this is what's going to be logged for your test. Now you can change this later on, because when you do a test, all it's actually doing is logging these values and then applying the selected correction. Most people are going to go with the SE J1349 correction. That is the most commonly used one now and accepted one. The sort of older version, the J607, that's also known as STP or STD. It gives slightly higher numbers the closer you are to sea level. Up here at Denver, they're not a huge difference. So we also have the German and Japanese standards as well. Those are similar to sort of the STP. Not really commonly used, but they're there just in case you want them. And lastly, uncorrected, obviously 1.0 correction factor. So we're going to go back to the J1349. We also have a density altitude. This was suggested by one of our customers. So I know a lot of people do like to see density altitude. I know that's used a lot at the quarter mile and all the drag strips and such. I don't do drag racing. I'm more of a road racing guy, but I do know that that is something that people appreciate. A pretty high density altitude here in Denver today on this hot March day. All right, so environmental corrections, that's out of the way. Logging control over here. So we have 2 options for logging control. Now, RPM is generally always going to be used for our engine dynos. However, you can use our systems on chassis dynos, and in that case, you probably want to use speed. Now, we're not going to talk about setup for a chassis dyno in this video today, but if you wanted all your logging control to be based upon start and end speeds, you simply change it with this drop-down menu. For now, we're going to go back to RPM. So with our sort of mock engine setup here, we can see we get down to around 800 RPM, and I believe we're maxing out at about 7,200. So for the purposes of this video, we're going to set our starting RPM to 2,500, and we'll set our ending RPM at 7,000. And by default, it will be an increasing sweep. However, if you wanted to do a decreasing sweep, you absolutely can, and you would click this checkbox right here to do a decreasing sweep. Now, in that case, your starting RPM would have to be higher than your ending RPM. So just keep that in mind. We have our test info, so test name and engine type. We'll call this RevBench demo, and engine type will be signal generator. All right, so when you're running a test, what you're going to want to do is make sure that you have your engine RPM below the start RPM, and then you'll arm the test. So we're below 2,500, and we're going to arm the test. Now, when it gets to 2,500, it will start logging automatically. So you can see it turns green, and it says test is running. Now, I'm kind of moving the torque just to kind of give us some cool results here by hand. And once it hits 7,000, you can see it stops. It freezes a little because it's dealing with a whole bunch of data, and it's going to automatically load our test viewer on completion of the test. So we can see here we're looking at measures versus RPM, and by default the engine torque and the power are always displayed. Power will be blue and engine torque will be red. We can see that we have our max power 102.3 at 5,938 RPM, and our max torque 93.9 at 5,562. I'm not going to go over the rest of the settings in our test viewer because that will be a completely separate video. But the point of this video was simply just to show how you can log a test. So I'm going to go ahead and close this out for now. So we mentioned the decreasing sweep option. So let's go ahead and do that now. So we're going to enable that, and we're going to say that our starting RPM is going to be still 7,000. And we'll make our end RPM to be 2,500. Decrease in sweep is checked. Now, peak threshold, what does this mean? Okay, well, when we're doing a decreasing sweep test, I want to be able to arm this test before I bring the engine up to a high RPM, because if I'm manually controlling a brake, it's going to be a total pain to deal with the software, the engine throttle, and the brake control all at the same time. I want to be able to be at a low RPM, click arm test, and then bring up the engine, and apply the brake. It gets difficult, right? So right now, let's say the engine's idling. I can click arm test, and it's ready to go. But what I have to do is exceed our starting RPM by this peak threshold value. So at 7,100, it's going to effectively arm the test. And then once it gets below 7,000, the test is running. So we can see the test is running now, and I'll play with the torque value just a little. And same thing as before, it'll automatically bring up our test viewer. So the decreasing sweep option, I know it maybe seems a little confusing, but the whole point of doing this is because we could be getting some noise in our RPM signal that would accidentally trigger the test when we're not ready at 7,000 RPM. So that's why we have to exceed 7,000 RPM, the starting RPM, by our peak threshold. So we have to bring it to 7,100 to effectively really arm it before it will start logging. Hopefully that makes sense. I know it's a little confusing, but trust me, it works really well once you kind of figure that out. All right, so let's say we don't want to do any sort of automatic logging control, and we just want to record a test and stop recording when we want. That's really simple. That's what the start manual logging is for right here. F12 on your keyboard is also a shortcut for that. But you can start logging whenever you want. So I just clicked it, and we can kind of play with the torque again a little over here. And then I can go ahead and click it again to stop logging. And once again, it'll bring up that test viewer automatically. All right, so we can see we have our 3 tests that we did. We have RevBench demo, all as our test names. You can see the number 7, 8, and 9. This is an increasing number, so It's basically, it starts at 1 when you first install the software, and it's always going to increase. This helps you kind of differentiate one run from another, or if you forget to input a test name. So again, we'll get more into details about the tests in a separate video. But for now, that should get you started with logging some tests. So thanks so much for watching. If you have any questions, please feel free to send me an email, Sean, S-E-A-N, at PrecisionDynoTech.com. And if you have any suggestions or you run into any problems, please don't hesitate to reach out. All right, thanks so much for watching, and I look forward to seeing you in the next one.